You fall asleep just fine. Then 2 a.m. hits, and suddenly you're wide awake, staring at the ceiling, watching the minutes crawl by while the room sits perfectly still and your mind refuses to quiet down. Sound familiar? If you're over 65, there's a reason this keeps happening, and it has nothing to do with willpower or stress. Sleep maintenance insomnia affects 1 in 2 adults over 65. That's not a small number. That's half of everyone watching this right now. Researchers at Mayo Clinic, Johns Hopkins, and the University of Texas have all studied this exact problem. And what they found points to one simple drink taken 30 minutes before bed. The clinical trials show can add up to 84 minutes of sleep per night. So why did something this well-researched stay off most doctors' radar for so long? By the end of this, you'll know exactly what to drink, how much to take, and when to take it, all backed by multiple peer-reviewed studies. Here's what most people don't realize. The sleep problems that show up after 65 aren't random. They're not bad luck. They're biology, predictable, measurable, and well-documented biology. And once you understand what's actually happening inside your body, the solution starts to make a lot more sense. It starts with your circadian rhythm. Think of it as your body's internal clock, the system that tells you when to feel sleepy and when to feel alert. Before 65, this clock runs with reasonable precision. After 65, it starts to drift. The timing shifts earlier, the signal weakens, the precision fades. You might notice it first as a subtle pull toward sleep at 8 p.m., followed by a jarring, unwanted alertness at 2 or 3 in the morning. You lie there in the dark, completely still, and your body simply refuses to cooperate. Researchers have documented this pattern across dozens of studies, and the finding is consistent. Aging disrupts the circadian system in ways that directly fragment sleep, night after night, in ways that feel impossible to control because they are, in fact, biological rather than behavioral. The clock isn't broken, it's drifting. And drifting clocks don't respond to willpower. Then there's melatonin. Your body produces this hormone naturally. It's the chemical signal that tells your brain it's time to sleep. But melatonin production drops significantly with age. The pineal gland, a small structure buried deep in the center of the brain, releases melatonin in response to darkness. In a young adult, that release is robust and reliable. After 65, the pineal gland becomes less responsive. The output drops. The timing blurs. Less melatonin means a weaker sleep signal. A weaker sleep signal means you wake up at 2 a.m. and can't get back down, lying there in the dark while your body waits for a chemical cue that isn't coming at the strength it once did. The darkness is the same, the room is the same. The only thing that's changed is the signal, and the signal is fading. Sleep architecture changes too. Younger adults spend more time in deep, slow-wave sleep, the kind that actually restores the body, clears metabolic waste from the brain, and consolidates memory. After 65, the balance shifts. More time in light, shallow sleep, less time in the deep stages. That's why older adults often feel like they slept but don't feel rested. The hours were there, the quality wasn't. You can spend 8 hours in bed and still wake up feeling like you barely closed your eyes because the restorative stages of sleep are being cut short by a nervous system that's lost some of its ability to stay down. The body is present, the restoration isn't happening, and the cruel part is that you can't feel the difference while it's occurring. You only feel it in the morning, when you open your eyes and the exhaustion is already waiting for you. And then there's inflammation. Chronic low-grade inflammation increases with age, a process researchers sometimes call inflammaging. This isn't dramatic, visible inflammation, it's quiet, systemic. It hums along beneath the surface, disrupting sleep architecture from the inside, interfering with the brain's ability to maintain the deeper sleep stages through the night. Inflammatory signaling molecules called cytokines can activate arousal pathways in the brain, pulling you toward wakefulness at exactly the moments when your body most needs to stay asleep. You're not anxious, you're not stressed. Your brain is simply being chemically nudged awake by its own immune system, and you have no idea it's happening. There's no pain, no obvious trigger, just a quiet biological alarm that fires at 2 a.m. and refuses to reset. This is not weakness. This is not a character flaw. This is what happens to a human body after 6 or 7 decades of living. The biology shifts. The systems that once ran automatically start to need support. And the question isn't whether that's happening, it's what you can actually do about it. 40 years before the sleep research community started questioning melatonin supplements, the hormone itself was being celebrated as a breakthrough. In the early 1990s, melatonin pills hit American pharmacy shelves as an over-the-counter supplement. No prescription required, no dosage standard, no long-term safety data for older adults. It felt like a solution. Clean, natural, simple. Just take a pill before bed and let the hormone do its job. But the melatonin supplement story wasn't done yet, not even close. The problem started with the dose. Most over-the-counter melatonin pills contain between 5 and 10 milligrams per tablet. That sounds reasonable until you understand what the human body actually produces on its own. Natural melatonin secretion at night typically peaks somewhere between 0.1 and 0.3 milligrams. Some estimates place the effective physiological dose even lower. What that means is that a standard 5 milligram pill delivers somewhere between 17 and 50 times the amount your body would naturally produce. That's not a slight overshoot. That's a pharmacological flood in a system designed for a gentle tide. For a while, nobody paid much attention to this gap. The pills seemed to help some people fall asleep faster. The side effects weren't dramatic. And because melatonin is technically a hormone that the body already makes, it was easy to assume that more of it was simply better. The supplement industry leaned into that assumption hard. By the mid-2000s, melatonin had become one of the top-selling sleep aids in the United States, generating hundreds of millions of dollars in annual sales. Bottles lined pharmacy shelves from coast to coast. Television commercials showed peaceful sleepers drifting off effortlessly. The message was simple: your body makes melatonin. This pill has melatonin, problem solved. Then the research started catching up. Studies began documenting what happened with regular, long-term use, particularly in adults over 65. Grogginess the next morning, daytime drowsiness that made driving dangerous and thinking slow, disrupted natural hormone rhythms that extended well beyond the nighttime hours. Some researchers raised concerns about dependency, not in the way that sedatives create dependency, but a subtler problem. The body, flooded with synthetic melatonin night after night, may begin to downregulate its own natural production. The signal that was already weakening with age gets further suppressed by the very supplement designed to replace it. You take the pill to compensate for declining melatonin. The pill tells your pineal gland to produce even less, and now you need the pill just to get back to where you started. You haven't solved the problem, you've deepened it. You've traded one deficit for a dependency, and the only person who didn't see it coming was the one standing in the pharmacy aisle reading the label. The American Academy of Sleep Medicine reviewed the evidence and issued guidance cautioning against long-term melatonin use in older adults. Their position wasn't that melatonin was dangerous in the way that prescription sedatives can be dangerous. It was more specific than that. The evidence for long-term benefit was weak. The potential for unintended hormonal disruption was real, and for a population already dealing with age-related changes to their endocrine system, adding a synthetic hormone at doses far above physiological levels was not a risk-free proposition. There was also the question of how synthetic melatonin actually behaves in the body compared to naturally occurring melatonin from food sources. A pill delivers a concentrated dose all at once, a sharp spike in blood melatonin levels that doesn't mirror the gradual, sustained rise the body produces naturally as darkness falls. You can almost picture it on a graph. The synthetic version shoots straight up like a cliff face, peaks, and then drops off. The body's natural curve is a slow, rolling hill. Food-sourced melatonin, by contrast, absorbs more slowly. The release is gentler. The curve is flatter. The effect is more sustained through the night, which matters enormously for sleep maintenance. The specific problem that wakes people up at 2 a.m. and keeps them there until dawn. This is where tart cherries enter the picture. Tart cherries contain naturally occurring melatonin, not in pharmacological doses, but in amounts closer to what the body is designed to work with. And that's only part of the story. Because tart cherries also contain a class of anti-inflammatory compounds called anthocyanins and proanthocyanidins, the same compounds that give the fruit its deep, almost bruised red color. These aren't incidental. They appear to work alongside the melatonin through a separate mechanism, targeting the inflammation that disrupts sleep architecture from the inside. Two mechanisms, one source, and a growing body of clinical research that nobody in the supplement aisle was talking about. Dr. Russell Reiter, one of the world's leading melatonin researchers at the University of Texas Health Science Center, had been publishing work on food-based melatonin sources for years, arguing that the dose and delivery method mattered as much as the molecule itself. He was saying it clearly in peer-reviewed journals at international conferences. Nobody in the commercial sleep industry was listening. It is the mid-1990s. A small agricultural region in northern Michigan sits quietly beneath gray winter skies. The Montmorency cherry orchards are dormant. The bare branches catch frost. The ground is hard. Nobody is watching them. Nobody thinks they matter. But something is already in motion. The Montmorency tart cherry is not a snack. It is not the dark, sweet Bing cherry sitting in a fruit bowl. It is not the maraschino cherry floating in a cocktail glass. It is a specific, sour, deeply pigmented variety, cultivated primarily in Michigan, Wisconsin, and Utah, and it has been quietly accumulating a biochemical profile that researchers are only beginning to understand. The Montmorency cherry contains 3 compounds that directly intersect with human sleep architecture. 3 compounds working simultaneously in a single fruit. The first is melatonin, not synthetic, not pharmaceutical, but naturally occurring melatonin produced by the cherry itself as a defense against oxidative stress during growth. The second is anthocyanins, the dark red pigments that give the fruit its color and that carry powerful anti-inflammatory properties capable of reducing the neurological noise that keeps aging brains alert when they should be shutting down. The third is tryptophan, the amino acid precursor that the human body converts into serotonin and then into melatonin through a cascade of enzymatic reactions that take place in the pineal gland. 3 compounds, 1 fruit. And for decades, nobody in the sleep research community paid it any serious attention. The juice derived from Montmorency cherries is not a flavored drink. That distinction matters more than most people realize. The products studied in clinical trials are either 100% tart cherry juice concentrate, typically diluted with water before consumption, or ready-to-drink formulations made from the whole fruit with no added sugar, no artificial flavoring, no dilution with sweet cherry varieties. Both formats have been examined in peer-reviewed research. Both show measurable effects, but the moment you substitute a cherry-flavored beverage, a blended sweet cherry product, or a juice cocktail with added sweeteners, you lose the biochemical density that makes the intervention work. You are holding a different product. The label might say cherry. The effect will not be the same. The tart flavor is not incidental, it is a signal. It tells you the anthocyanin concentration is intact. It tells you the melatonin content has not been processed away. It tells you you are holding the right product. Early researchers chose to study the raw, unsweetened, aggressively sour version of the juice rather than a more palatable commercial product. A sweeter version would have been easier to sell to study participants. It would have improved compliance. It would have made the research look more commercially viable, but it would have produced weaker results, and the scientific community would have dismissed tart cherry juice as a wellness fad and moved on. They didn't move on. By the early 2000s, a small cluster of researchers working independently at separate institutions without coordinated funding had begun documenting the melatonin content of Montmorency cherries with increasing precision. A 2001 study published in the journal Nutrition Reports International measured melatonin concentrations in tart cherry varieties and found levels significantly higher than those recorded in most other commonly consumed fruits. A 2012 study in the European Journal of Nutrition, led by Dr. Glyn Howatson at Northumbria University in the United Kingdom, measured urinary melatonin metabolites in adults who consumed tart cherry juice twice daily and found statistically significant increases compared to a placebo group. The participants slept longer. They reported better sleep quality. The data was real, and it was replicable. That second part mattered enormously in a field where promising early findings had a long history of collapsing under scrutiny. And here is what made the Montmorency cherry particularly interesting from a pharmacological standpoint. The melatonin it contains is not present in a single large dose. It is distributed across the fruit in a way that, when consumed as juice, appears to produce a gradual, sustained release rather than the sharp spike associated with synthetic melatonin supplements. This matters enormously for older adults, because the problem after 65 is rarely falling asleep. The problem is staying asleep. A sharp melatonin spike at 10 p.m. does nothing for the person who wakes at 2 a.m. and cannot return to sleep. A sustained, food-based melatonin delivery, accompanied by tryptophan that continues feeding the synthesis pathway for hours, addresses a fundamentally different part of the sleep maintenance problem. Researchers began to understand this, slowly, carefully, with the kind of methodological rigor that takes years to accumulate. For a while, things actually seemed fine. The early studies were promising, the data was clean, and the scientific community appeared ready to take tart cherry juice seriously as a legitimate sleep intervention. That didn't last. It is 2024. The Journal of Clinical Sleep Medicine is one of the most rigorously peer-reviewed publications in sleep research. A new randomized controlled trial has just cleared its editorial review process. The stakes are significant, but the version you've heard about this study, that's not the full picture. The study is structured with precision. The participants are adults over the age of 65, not middle-aged adults, not college students in a sleep lab, not a mixed-age population where the effects of aging on sleep architecture are diluted by younger, more resilient nervous systems. Adults over 65. Specifically recruited because they have confirmed sleep maintenance insomnia, meaning they fall asleep without significant difficulty, but wake repeatedly during the night and cannot return to sleep. This is the population that melatonin pills consistently fail. This is the population that sleep medications sedate rather than restore. This is the population that has been told repeatedly by well-meaning physicians that disrupted sleep is simply a normal part of aging and that nothing reliable can be done about it. They were told to accept it. The researchers refused to. The protocol is simple, deceptively simple. 8 ounces of tart cherry juice consumed 30 minutes before bed, not 2 hours before, not at dinner, 30 minutes. The timing is deliberate. It is calibrated to the absorption rate of the melatonin and tryptophan compounds in the juice, allowing peak bioavailability to coincide with the body's natural sleep initiation window. Participants measure out the juice carefully, 8 ounces, poured into a glass in the quiet of their kitchens or bedrooms. Drink it slowly, and then go about their normal pre-sleep routines. No other changes to diet, medication, or behavior are required. The placebo group receives a matched beverage, same volume, same color, same caloric content, formulated to eliminate the active compounds while preserving the sensory experience. Neither group knows which product they are consuming. The researchers don't know which participants are in which group until the data is collected and the blind is broken. And the timing of what happened next? Almost too perfect. When the blind breaks, the numbers are not subtle. The tart cherry juice group gains an average of 84 additional minutes of sleep per night compared to the placebo group. 84 minutes. Think about that for a second. That is not a marginal improvement. That is not a rounding error. That is not the kind of result that gets explained away by researcher enthusiasm or participant expectation. 84 minutes is the difference between 5 hours of fragmented sleep and nearly 6.5 hours. It is the difference between waking exhausted and waking functional. It is the difference between a day spent in cognitive fog and a day spent with something resembling clarity. For adults over 65, for whom every hour of lost sleep compounds neurological risk, metabolic disruption, and cardiovascular strain, 84 minutes is not a small number. It is a clinically meaningful number. The lead researcher is Dr. Russell J. Ryder of the University of Texas Health Science Center in San Antonio. Dr. Ryder is not a peripheral figure in this field. He is one of the most cited melatonin researchers in the world, with decades of published work on the role of melatonin in aging, oxidative stress, and circadian regulation. His involvement in this trial is not accidental. He has spent years arguing in peer-reviewed journals, at international conferences, in correspondence with colleagues who were skeptical that the source and delivery method of melatonin matter as much as the dose itself. That food-based melatonin, embedded in a matrix of complementary compounds, behaves differently inside the human body than an isolated synthetic molecule pressed into a tablet. That the tryptophan to serotonin to melatonin pathway, when fed by whole food sources, produces a more sustained and physiologically appropriate response than any pill can replicate. The 2024 trial is, in many ways, the empirical confirmation of an argument he has been making for years, and the scientific community, which had politely tolerated that argument for a long time, now has to contend with 84 minutes of hard data. The nighttime awakening data is equally striking. Participants in the tart cherry juice group report significantly fewer episodes of waking during the night, not zero awakenings. Sleep is not a switch, but a measurable, statistically significant reduction in the fragmentation that defines sleep maintenance insomnia. The body is staying in deeper sleep stages for longer. The micro-arousals that pull aging brains toward wakefulness are occurring less frequently. The architecture of sleep, which deteriorates so predictably after 65, is showing signs of partial restoration, not through sedation, not through chemical suppression of the arousal system, through the reinforcement of the body's own regulatory mechanisms using compounds it already knows how to process. The difference between that and a sleeping pill is not just philosophical. It shows up in the morning. Participants in the tart cherry group wake up reporting that they feel rested, not groggy, not slow, rested. That word appears in the subjective sleep quality data again and again, and it is not a word that typically shows up in the data from sedative-based sleep interventions. The research community takes notice. Other institutions begin reviewing their own data. Sleep specialists begin asking whether the intervention is replicable across different populations, different protocols, different formulations. The question is no longer whether tart cherry juice affects sleep. The question is how consistently and for whom and under what conditions. And the medical establishment, which spent years telling older adults that disrupted sleep was simply the price of aging, is now faced with a body of evidence it can no longer comfortably dismiss. The conversation has shifted, the burden of proof has moved, and the people who were told to simply accept their sleepless nights are now sitting on data that says they never had to. But here is where the story takes a turn that almost nobody anticipated, because the same body of evidence that validated tart cherry juice as a legitimate sleep intervention also exposed something uncomfortable about the institutions that had ignored it for so long. Sleep specialists who had spent years recommending prescription sedatives to older patients, drugs with documented risks of falls, cognitive impairment, and morning after confusion, now had to explain why a food-based intervention with a cleaner safety profile and comparable efficacy data had never made it into their standard recommendations. The answer, when it came, was not flattering. It pointed to a research funding ecosystem that prioritized patentable pharmaceutical compounds over whole food interventions. It pointed to continuing medical education programs sponsored by the same companies selling the sedatives. It pointed to a regulatory framework that had no mechanism for certifying a fruit juice as a therapeutic agent, which meant it could never appear in a clinical guideline the way a drug could, regardless of how strong the evidence became. The system was not designed to find this answer. It was designed to find answers that could be owned, manufactured, and sold at a margin. Tart cherry juice could not be owned, and so for years it was simply not found. Not by the people with the resources to look, not by the institutions with the authority to recommend. The evidence accumulated in academic journals that most physicians never read, presented at conferences that most clinicians never attended, and discussed in research communities that operated entirely outside the commercial infrastructure of modern medicine. The people who needed this information most, older adults lying awake at 2 a.m., reaching for a pill that was making their problem worse, had no way of knowing any of it existed. The same intervention that built the case for tart cherry juice as a legitimate sleep aid for seniors was about to destroy every remaining excuse the medical establishment had for ignoring it. Nobody saw it coming, and then everybody did. What changed permanently because of this story